Hello. Good evening, students. लास्ट लेक्चर में हम लोगों ने डिस्कस किया था एपिसाइक्लिक गियर ट्रेन्स और रिवर्टेड गियर ट्रेन्स पे। आज एपिसाइक्लिक रिवर्टेड गियर ट्रेन के कुछ न्यूमेरिकल्स हम लोग सॉल्व करेंगे, डिस्कशन करेंगे, और कंपाउंड एपिसाइक्लिक गियर ट्रेन के बारे में जो सन एंड प्लैनेट गियर्स ट्रेन के बारे के नाम से भी जाना जाता है। तो सबसे पहले रिवर्टेड एपिसाइक्लिक गियर ट्रेन पर बेस्ड एक न्यूमेरिकल सॉल्व करते हैं। जैसा कि आप जानते हैं, एपिसाइक्लिक गियर ट्रेन की अगर हम बात करें तो इसमें अगर कोई गियर किसी दूसरे गियर के सरकमफ्रेंस के अलाउंग अपनी एक्सिस के अबाउट भी, और गियर लेट सपोज गियर बी rotates about the circumference of the gear A also, and gear B rotates about its center, and gear A rotates about its center, then this type of gear train is known as epicyclic gear train. तो यहाँ पर हम देख रहे हैं हमारे पास चार गियर्स हैं, बी सी डी ई, और ये एक रिवर्टेड एपिसाइक्लिक गियर ट्रेन यहाँ पर फॉर्म कर रहे हैं, बना रहे हैं। यहाँ पर एक आर्म है ए जो गियर बी और सी को एक एक्सेस पर, एक शाफ्ट पर, और डी और ई को अनदर शाफ्ट पर होल्ड किए हुए। नाउ इन ए रिवर्टेड एपिसाइक्लिक गियर ट्रेन, the arm A carries two gears B and C and a compound gear DE. The gear B meshes with the gear E and the gear C meshes with the gear D. The number of teeth on gears B, C, D are 75, 30 and 90 respectively. Find the speed and direction of gear C when gear B is fixed and the arm A makes 100 rpm clockwise. Okay. We will solve this problem by tabular method. So first of all, given TB, number of teeth of gear B on gear B is 75. Number of teeth on gear C is 30, and number of teeth on gear D is 90 respectively. Okay. RPM of arm A is given 100 rotation per minute. First of all, find out the number of teeth on gear E. Let number of teeth on gear E are TE. Okay. And pitch circle diameters of gear E is DE. Pitch circle diameter of gear B is DB. Pitch circle diameter of gear C is DC. Pitch circle diameter of gear D is DD. Gear B, C, D, E forms a reverted gear train. So, diameter of gear B, pitch circle diameter of gear B plus pitch circle diameter of gear E should be equal to the pitch circle diameter of gear C plus pitch circle diameter of gear D. Since the number of teeth on each gear for the same module are proportional to their pitch circle diameter, therefore TB plus TE is equal to TC plus TD. Now from here TE will be equal to the TC plus TD minus TB. TC is 30, TD is 90, TB is 75. So number of teeth on gear E will be equal to the 45. Now table of motion. First of all, serial number. Second, conditions of motion. Revolutions of elements. Arm A, compound gear DE, gear B, and last gear C. No. Condition of motion. First condition, arm fixed compound gear DE rotated +1 revolution in counterclockwise. Okay, arm fixed. If the arm is fixed, then the speed of the arm is 0. Arm fixed, compound gear DE rotated +1 rotation. So compound gear having counterclockwise rotation has been taken as positive. So in that case, the speed of the gear B will be equal to the minus TE upon TB, and for the gear C will be equal to TD by TC. The second condition, arm fixed, compound gear DE rotated through plus X revolutions. Now again arm is fixed, then speed of the arm is 0. It will be equal to plus X. compound gear train की जो speed है वो plus X. Now in that case gear B has X into TE by TB minus gear C has TD by TC. Now the third condition, add plus Y revolutions to all elements. Plus Y, plus Y, plus Y and plus Y. Now the total motion will be equal to the plus Y arm for compound gear train X plus Y, for gear B Y minus X TE upon TB, and for the gear C Y minus X TD by TC. Okay, since the gear B is fixed, therefore Y minus X TE by TB should be equal to 0, or Y minus X TE is given 45, TB is 75 equals to 0. From here y minus 0.6x will be equal to 0. The arm A makes 100 RPM clockwise. Therefore, y is equal to the minus 100. Now from the above equation, minus 100 minus 0.6x will be equal to 0, and x is equal to the minus 166.67. Okay. Now we have to find the speed of the speed and direction of the gear C, and the gear B is fixed. Now the speed of the gear C will be equal to the y minus x td by tc. So from here, y is minus 100, this is equal to 166.67, td is 90 and tc is 30. Now 100 plus 166.67 into 3, it will be equal to the plus 400 rotation per minute. Positive sign shows that gear C will rotate in counterclockwise direction. Okay. Now come to the next topic, which is compound epicyclic gear train, or says sun and planet gears. A compound epicyclic gear train consists of two coaxial shafts, S1 and S2. An annulus gear A, this is the annulus gear A. The annulus gear have internal teeth. The compound gear or planet gear BC, gear B and C are mounted on the same shaft. These are the compound gears. So gear B and C are the compound gears, and these gears are also known as planet gears. Planet gears, because this gear rotates about the center gear D. The center gear D is known as sun gear. This gear is known as sun gear. The sun gear connected with the gear C this gear is connected with the gear C, and gear C and gear D are the compound gear mounted on the same shaft, and the gear D is connected with the NLS gear. Gear B is connected with the NLS gear A. Okay, the sun gear is coaxial with the NLS gear, with the NLS gear and the arm, but independent of them. Okay, the NLS gear A matches with the gear B. NLS gear is matched with the gear B. NLS gear has the internal teeth, and gear all of other B, C, D gears has external teeth. Okay, so the NLS gear A matches with the gear B, and the sun gear D matches with the gear C. If the NLS gear is fixed, the sun gear provides the drive, and when the sun gear is fixed, the NLS gear provides the drive. Okay. In both cases, the arm acts as a follower. Now, let TA, TB, TC, and TD are the number of teeth on the gears A, B, C, D respectively, and the speed of the gear A, B, C, D, R, and A, N, B, N, C, and ND. A little consideration will show that when the arm is fixed and the sun gear D is turned anti-clockwise, then the compound gear BC and the NLS gear A will rotate in clockwise directions. Now we can understand the motions of the gear train with the help of the table of motion. Step number 1, first condition of motion is arm fixed, gear D rotates through +1 rotation. Sun gear rotates with +1 rotation. If the sun gear rotates in +1 rotation, in that case, see, then the speed of the gear BC, compound gear BC, will be equal to the because gear D matches with the gear C, so NC upon ND will be equal to the TD by TC, or NC will be equal to the ND TD by TC. If gear D rotates in counterclockwise direction, in that case gear C will rotate in clockwise direction. So clockwise direction has been taken as negative. Then, and if the sun gear rotates with uh, rotates with one revolution, then in that case the speed of the compound gear BC will be equal to the minus TD by TC. Okay. Now gear B matches with the gear A, so speed of gear A will be equal to the minus speed of gear B into TB by TA. Now the second step, when the arm is fixed arm fixed, gear D rotates through plus x revolution, then in that case, the speed of the arm will be 0. Gear D will rotate with plus x rotation. Gear compound gear train, the compound gear speed of compound gear BC will be is equal to minus x TD into TC, and similarly the gear A minus x TD by TC into TB by TA. Now add plus y revolution to all the elements. Arm rotates with plus y rotation, gear D rotates with plus y, compound gear BC and gear A. Now the total motion of arm will be plus y. Gear D rotates with x plus y. Compound gear BC y minus x into TD by TC, and gear A y minus x TD by TC into TB by TA. Okay, we can calculate the speeds of the gear speed of the any gear in a epicyclic gear train. Now an epicyclic gear consists of three gears A, B, C as shown in figure. The gear A has 72 internal teeth. Gear A is a NLS gear. And gear C has 32 external teeth. Okay. The gear B matches with both gear A and C and is carried on arm EF, which rotates about the center of A at 18 rpm. If the gear A is fixed, determine the speed of gear B and C. Okay. Given. Write down first the data given in the numerical. Number of teeth on gear A is given, which is 72. Number of teeth on gear C has been given, which is 32. Speed of the arm EF has been given 18 rotation per minute. Now draw the table of motions. Step 1, step numbers first. Second, conditions of motion. Next, revolution of elements. Arm EF, gear C, gear B, gear A. First step, arm fixed, gear C rotates through +1 revolution. Counterclockwise. Now, arm is fixed and speed of the arm is 0. Gear C rotates in counterclockwise direction with 1 revolution. In that case, speed of the gear B will be minus Tc by Tv, and the speed of gear A will be equal to minus Tc by Tv into Tb by Ta minus Tc by Ta. Second step, arm is fixed, gear C rotates through +x revolutions. Speed arm is 0. Gear C rotates with +x. Gear speed of gear C will be gear B will be minus x Tc by Tv, and speed of gear A will be minus x Tc by Ta. Now, step 3, add +y revolutions to all elements. Now the total motion will be for the arm EF is +y, for the gear C will be x plus y, for the gear V will be y minus x Tc by Tv, and for the gear A will be y minus x Tc by Ta. So this will be the final equations for the speed of the gear C, gear B and gear A. Now we know that speed of arm EF is given 18 rotation per minute. So y will be is equal to the 18 rotation per minute, and the gear A and gear A is fixed, so y minus x Tc by Ta will be equal to 0. Y is given 18. Number of teeth of gear C is 32. Number of teeth of gear is 72, equals to 0, or x will be equal to the 40.5 rotation per minute. Okay. Now speed of gear C will be equal to, has been equal to the x plus y. So speed of gear C will be x is 40.5, y is 18, and 58.5 rotation per minute. Gear C rotates in counterclockwise direction. Okay. Now the speed of gear B First of all, we have to calculate the number of teeth on gear B. Here, let dA, dB and dC be the pitch circle diameter of gear A, B, C respectively. Now, from here, radius of the pitch circle of the gear A will be equal to the diameter of gear B plus radius of sun gear C. Okay, diameter of gear B plus radius of gear C equals to the radius of the analogous gear A. Since the number of teeth are proportional to their pitch circle diameter, therefore 2 dB plus dC is equal to dA, or 2 TB plus TC is equal to TA. Now, number of teeth on gear C is 32. Number of teeth on gear A is 72. Now the number of teeth on gear B will be 20. So the speed of gear B will be equal to the y minus x Tc by Tb as written in the table of motion. So the speed of the gear B will be y is equal to 18, x is 40.5, number of teeth on gear C is 32, number of teeth on gear B is 20. So the speed of the gear B will be equal to the minus 46.8 rotation per minute. Minus sign shows that gear B will rotate in clockwise direction. Now, an epicyclic train of gears is arranged as shown in figure. How many revolutions does the arm to which the pinion B and C are attached make first when A makes one revolution clockwise and D makes half revolution anti-clockwise? Second, when A makes one revolution clockwise and D is stationary, the number of teeth on each gear A and D are 40 and 90. Number of teeth on gear A is 40. Number of teeth on gear D are 90. Now table of motion. Now see, table of motion. First, step 1. Arm fixed. If arm is fixed, then speed of the arm is 0. Gear A rotates through minus 1 revolution. Gear A is a sun gear and it rotates with minus 1. 1 revolution in clockwise direction. Now the compound gear BC is matched with the gear A. In that case, speed of gear B upon gear A will be equal to number of teeth on gear A upon number of teeth on gear B. Here, if the gear A rotates in clockwise direction, then gear B will rotate in anti-clockwise direction. So, the rotation of gear A is 1, then in that case, the speed of compound gear BC will be plus TA upon TB. Now the gear D meshes with the gear B. Similarly, speed of gear D upon speed of gear B will be equal to the number of teeth on gear P upon number of teeth on gear D. Here NB is equal to TA by TB, then in that case TA upon TB will into TB by TD is equal to the speed of the gear D, and it will be equal to the TA by TD. Okay. Now second step is arm fixed, gear A rotates through plus minus x revolution. It means clockwise direction. So the equation will be minus x plus x ta upon tb plus x ta upon td. Okay. Add minus 1 revolutions to all elements. Rotates all elements in clockwise direction with y. Minus y minus y minus y. And the total motion of the arm will be minus y x minus y. X into ta by tv minus y is the compound speed of compound gear BC. X into ta by td minus y is the speed of the gear D. Now first, speed of the arm A when makes one revolution clockwise and D makes half revolution anti-clockwise. So the A makes minus 1 revolution. The speed of gear A is given by minus x minus y equals to the minus 1. So from here x plus y will be equal to the 1. This is the equation number 1. Second, the gear D makes half revolution. The speed of the gear D is given by this equation. From here x ta by td minus y equals to the 1 by 2. From here x minus 2.25y will be equal to the minus 1.125. Solve these equation, we will get x is equal to the 1.04 and y is equal to the minus 0.04. So the speed of the arm will be minus y. So the speed will be plus 0.04 rotation per minute. It means in and counterclockwise direction. Now second, speed of arm A when makes one revolution clockwise and D is stationary. So minus x minus y is equal to the minus 1. So from again from here x plus y is equal to 1. Now the speed of the gear D is x into ta by td minus y equal to the 0, or x minus 2.25y will be equal to the 0. Now solve these equation. X is equal to the 0.692. By solving these equation, we will get x is equal to 0.692 and y is equal to 0.308. Now the speed of the arm will be equals to the y minus y. So it will be equal to minus 0.308 rotation per minute, which shows that arm rotates in clockwise direction. Okay. Okay. Thank you very much.